Now, technically, this is still considered microscopic anatomy as we look at the parts of the tissues or as we look at the individual cells of the tissues. Now, remember, atoms make up compounds. Now, we looked at the compounds. We looked at elements. We looked at elements in nutrition, what we need to take in for food. We looked at the compounds, the molecules that make up ATP, DNA, RNA, carbohydrates, proteins, and we briefly went over what organelles produce those proteins or produce the energy. Then we started moving into the individual parts of the cells, and now we're moving into the actual tissue. That will then lead us into the actual systems later on. We'll first start with the integumentary system, which is the skin. Now, make sure you're aware that tissues are groups of cells that carry on a similar structure and function. So you have bone cells that do only things that bone cells do. You have muscle cells that do what muscle cells do. So they are specific to that category or that grouping of tissues. So the same type of cells work together to carry out a specific function. Now we're going to focus on 4 types of tissues, and within those types of tissues there's going to be different systems that we're going to talk about later on, but let's kind of introduce those tissues. The first one is the epithelial tissue, which primarily describes the skin, but it's not just the skin. The epithelial tissue is a soft tissue that's usually maybe in the lining of the nose and throat. It could be in the lungs. So it's a lot of different places. It can be in the intestines as well. Then we have the connective tissue, and that's not just bone, but that's tendons, ligaments, cartilage. So there's going to be a lot of different types of connective tissue. Then we have the muscular system, which is more basic. We have 3 different types of muscles that we'll address, and we'll learn more about that in those chapters. And then we have the nervous tissue, and primarily we're going to divide that into 2 categories. The central nervous system, which is the brain and spinal cord, and the peripheral nervous system, which are the nerves that branch out into the arms and legs. But we will address what a neuron, a basic nerve cell, is going to look like in this category of tissues. So let's talk about epithelial tissue. Be aware of some of the different locations. As we said, it's not just the skin, but this can be in the kidney, the trachea, which is the breathing tube, the lungs, different glands in the intestine, especially the small intestine. Some characteristics and functions of this: they can attach to underlying tissue. This is specifically seen in the basal skin cells or the bottom skin cells. These cells can protect and act as a barrier, such as the skin. Within the integumentary system, you're going to have blood vessels. You're going to have nerve cells that detect temperature, pressure, pain. You do have epithelial tissue in your lungs, which help with diffusion of oxygen. Also, you will have little cilia that will filter things out, maybe moving mucus out of the lungs. You're going to have glands that will secrete and excrete different materials such as oil or sweat. And then you have absorption through little villi or microvilli, which are like little fingers in the small intestine that absorb nutrients into the bloodstream. And we're going to first focus on the 2 main types of classification here, and it's pretty basic memorization. You have simple epithelial cells. Simple refers to a 1 layer, while stratified means many layers, more than 1 layer. Then we're going to combine that number of layers, that category of simple and stratified, with the shape of the cell. So when you see squamous, it's flat. So you can have simple squamous, you can have stratified squamous. Then we have cuboidal, which is very easy to remember, cube shaped, so that's square shaped. So you can have simple cuboidal, simple or stratified cuboidal. So stratified cuboidal would be many layers of cube cells. Then we have columnar, which are column or pillar shaped. So we can have simple and or stratified columnar cells. Then we have transitional. Transitional are the stretchy kind of cells that maneuver and change shape. And then we have pseudostratified columnar. These are column cells that actually look as they kind of stretch out. They're thinner at one part than another. So they look like they have many layers or multiple layers, but as it's real thin in one section and thickens in another section, it just looks like it's at maybe a top or lower section, but it actually is just one layer. So pseudostratified basically is referring to pseudo meaning false or fake. So it's referring to a fake stratified, but it's actually just one layer. So it would be actually simple columnar. But because of the shape of those cells, we identify it as something that stands out as pseudo-stratified columnar cells. So you can take a look at the different shapes here and layers. Now, some of the different additional structures that are hooked to or part of your epithelial cells would include microvilli, which are like little fingers. As we said, this is perhaps found in the small intestine. These have blood vessels within these little extensions that absorb the food nutrients to bring it to the bloodstream. So when you eat food, remember we're breaking down that food into compounds, into elements, and these villi, these microvilli, absorb in the elements, and basically the blood, the capillaries pick up these nutrients and send it throughout the body, sends it to the cells from the small intestine. And then we have blood vessels, which are capillaries, and basically the capillaries will line the bottom of the cells or between the cells, and as it's very similar to the epithelial villi, they're going to maybe absorb or even send white blood cells, maybe if there's an infection or damage to the skin cell. Maybe it needs to release heat or absorb heat. So these blood vessels have different functions, and they also help reduce some friction with and around the cell. Now, not just microvilli, these little extensions that could be on top of a cell or on the side of the cell, but you may have cilia. Now, cilia are more like, they're kind of like microvilli, but they don't really have the blood vessels within them. They are more hair-like. They move materials across the surface of the cell membrane. Maybe they might try and move the material out of the lungs. Now, the cilia is primarily within maybe the paramecium for movement, but in this case, it's not for movement. It's not to move the whole cell. It's actually to move the things that maybe don't belong in the lungs, to move it out or move things to a certain location. So these hair-like structures will kind of move in a pattern to move things out. Then we have goblet cells. Now, a goblet is like a long glass-like cup, and basically these cells produce mucus, and this is primarily found in the stomach. And then we have different types of glands. There are exocrine glands and endocrine glands. Now, glands are primarily going to secrete substances onto the surface of the cell or onto the surface of the skin, or perhaps even into a cavity, into a space, or even into the blood. So if it's moving it out, it would be exocrine. If it's going to be moving or secreting substances in the body or inside, that would be endocrine. So an exocrine gland is going to be something like sweat or sebaceous glands, and sebaceous means oil. So it's secreting it out of the body, so onto the surface of the skin. While the endocrine glands are going to secrete materials into the blood. This is going to be like the thyroid gland or the thymus gland. Remember, the thyroid gland is in the neck, or the pituitary gland, which is in the brain. So these secrete hormones or materials directly into the bloodstream. Here are some pictures of the different glands, and you can see that opening at the top where that material will be excreted out of and from where it's producing. So you can see some of the sebaceous or oil glands. You can see some of the basic, some of the different mucus glands of the small intestine. That's the duodenum, which is part of the small intestine. You have the mammary glands, which produces milk for the offspring, and you have different glands in the stomach and large intestine. Now we're going to move into connective tissue, and as we said, connective tissue not just talks about bones, but we're talking about cartilage, ligaments, tendons, but also it talks about blood and adipose. Now, this not only refers to bones, but also cartilage, ligaments, and tendons. And what primarily is overlooked is blood is a connective tissue, as well as fat cell that holds the lipid. Now, some characteristics and functions describe connective tissues, as we said, tendons and ligaments. It's going to connect tissues together. It can protect, such as the bone, the ribs, protects the heart and lungs. The vertebrae, protects the spinal cord. But we also have protection coming from the white blood cells, the immune cells in the blood. Then we have support, providing movement, specifically in bones. We have cartilage, fat, and bone, which encloses and separates. The fat will separate maybe different layers of different tissues, maybe from a certain system, maybe from the integumentary, separating that from the muscular system, may separate the integumentary from. And we have storage, specifically the adipose tissue, we said stores fat, which is described as a lipid. We have transport, specifically in the blood, and then we have cushioning and insulation, as we said, with the adipose fat tissue. Now, there are two basic types of connective tissue. There's loose connective tissue, which basically separates the organs and the muscles and glands. It may be between those structures, but we're primarily going to focus on the dense connective tissue here, and that's going to be the tendons and ligaments. Now, tendons, this is something that you can write down. This would be a great bonus question for me to specifically check to see who's listening to the lecture video and who's not. But basically, tendons connect muscle to bone, while the ligaments are primarily going to be bone to bone. So when you're eating a chicken leg or some sort of meat, and that white kind of chewy portion that's at the end of the bone that's kind of hooked to the muscle and also hooked to the bone, that's going to be a tendon. But if you have a chicken wing and between the joints you may see a connection between the bone and bone, that's going to be a ligament. So tendon is connecting muscle to bone, while ligament is bone to bone. Then we have three types of cartilage. We have the hyaline cartilage, which covers the ends of the bone, ends of the long bone. This is primarily when we have, this is to reduce friction. But when we have people of older age getting knee replacements or hip replacements, this is because this hyaline cartilage has worn down. This may be because they're very active when they're younger in a lot of sports, and that hyaline cartilage rubs, and gets worn down, especially if they're participating in a lot of running sports. Then we have fibrocartilage, which is between the vertebrae. This is to absorb impact between the vertebrae so that the vertebrae is not like hitting or hurting. There's a lot of cushion there, and this takes in a lot of the compression and a lot of the impact from running and doing different activities. Then we have elastic cartilage or elastin cartilage. This is found in the nose and the ears. Now, I think it's a kind of common misconception that people say that elastic cartilage doesn't stop growing. I don't know if that's true, but what I have heard is that it does stop growing. Elastic cartilage does stop growing, and primarily the reason why older individuals may have a larger nose or larger ears is because of a couple different factors. Is that the fibers of the cartilage will start breaking down, and then you also have gravity, which is pulling on those structures, so kind of spreading them apart and kind of pulling them. So there are going to be different factors that impact the size of the cartilage. But primarily when you pull on your ears and your nose, they do recoil, they go back to the original position. Then we have adipose tissue, which is a cell or a container that fills or becomes filled up with lipids or your fat molecule. So remember, we talked about what a lipid is and the structure of the head and the fatty acid tail. So basically, that's why it's very hard if you've ever seen some of those TV shows like The Biggest Loser, and then you see them like 5 years later, they've gained all their weight back. It's because once you make that cell, that fat cell, and then you lose your fat, you're not making the fat cell go away. You're just collapsing the container. You're just emptying the container. So you still have the container there. So when you do eat a little bit, it's going to be easier to fill up that container than it is to make a new container. So that's why it's going to be very easy to gain your weight right back because you already have that container there and you're just filling up the extra fat in the tissue. Then we have two types of bone tissue. We have the spongy tissue, which contains spaces. This is more on the inside of the bone, while the compact bone contains the osteon, the structural units, the bone cells, which are called osteocytes, and this is more kind of concrete, more solid. Then we have blood, which consists of two parts. You have the liquid and the solid form parts. The liquid part is called plasma, and this makes up 55% of the total blood volume. And we can actually separate the plasma from the form parts, which are the red blood cells, white blood cells, and platelets. And we can do that by taking your blood and putting it in a centrifuge. Now, a centrifuge will spin around real fast and it will actually separate those parts. And here you can take a look at the microscopic views of the different tissues and an animation and an illustration. Also, here are some pictures separating or showing you the cartilage types, bone types, blood composition, and the bone structure, showing you the compact versus the spongy bone. And then we had the muscular types, and really we're just going to focus on three types of muscles. That's going to be your skeletal muscle, smooth muscle, and cardiac muscle. So your skeletal muscle primarily found on the bones, your smooth muscle in the intestines, and your cardiac muscle in the heart. And that's, of course, going to be used for movement, digestion, pumping the blood for circulation. Now, the skeletal muscle is going to be our only voluntary muscle. Voluntary means we can choose to move it, we can consciously think to move it. While the smooth muscle and the cardiac muscle is going to be involuntary, means that means we are not consciously thinking about digest, or oh, I got to pump my heart, pump. And if I get distracted, I'm going to die. No. So involuntary means I'm going to do it without thinking. Now let's go back to the skeletal muscle. We said it's voluntary, but it's going to have striations. Striations are little lines, little markers within that muscle. There's going to have many nuclei. While the smooth muscle does not have striations, cardiac muscles do have striations, but they also have something called intercalated discs, which look like a very thick separation between the branched muscle. And let's take a look at those types of muscles. Okay, so here you can see in the skeletal muscle, you can see the striations. You also have that on the cardiac, but you can see the clear intercalated discs, how much thicker they are, and they are a separation or a connection between the different muscle cells. And then the smooth muscle does not have striations. Now, the primary function of the striations or the striated muscle is to primarily contract and to generate a force for movement. This can be movement of the body and the bones, or this can be movement of the heart. Now let's move into the nervous tissue. Primarily, we're going to separate this into two specific parts. We're going to identify the central nervous system, which is going to be the spinal cord and the brain. And then make sure you know the spinal cord is protected within the vertebral column, and the brain is protected within the cranium, which is the brain case of the skull. And so that's the central nervous system. And then we have the peripheral nervous system. So the central nervous system is the CNS, while the peripheral nervous system is the PNS. And this is all other nerves of the body. This is the nerves that branch out into the arms and legs. And this is a relay between when you touch something hot, it sends the impulse up the arm to the spinal cord, up to the brain, and you're like, whoa, that's hot. Pull your hand away. So the brain sends that impulse back down the spinal cord, down through your arm, to your hand, and then your muscles react to move your hand from the hot image. And if you really think about how specifically designed that is, that happens instantaneous pretty much. You touch something hot, you pull away. So that impulse is rapidly moving. And so we're going to talk about the peripheral nervous system, but also the specific nerve cells. And you can see right here is a general neuron. As you can see here, this is a general neuron. As you can see here, this is a general neuron, which is a nerve cell. And you have the cell body, which is the soma with a nucleus inside. Around the cell body, you have dendrites, which receive the impulse from the other nerve cell. It sends the impulse down the long part, which is along the axon and through the myelin sheath. And then you have the synapse, which is the space between the axon and the new dendrites of the new neuron. Here we have the central nervous system versus the peripheral nervous system. Now, lastly, we're going to talk about tissue repair. Now, some cells can regenerate, but other cells will or cannot. They can just replace it with connective tissue, creating a scar. So if you have a heart attack, you damage the cardiac muscle. but you cannot replace it with new cardiac muscle. You would not regenerate it with new cardiac muscle. You would actually replace it with connective tissue, which is scar tissue. And of course, if that happens to the heart can't bend and move the way it was designed to and pump properly. So some cells can only replace it with scar tissue. Now, when an inflammation occurs and that tissue is damaged, white blood cells can, of course, come and protect that damaged area being sent through the blood, but we have swelling. Swelling is because of increased water. So water is sent to that area, also proteins. We're going to have a redness, which is caused by dilation of the blood vessels. So when your face gets red or there's a redness of an inflammation or a cut, that's because the blood vessels swell out. If you ever heard of dilation of the eyes, of the pupil gets large. So the blood vessels get large to send heat to that area. May also do that to absorb. And then heat caused by the increased blood flow, and then we have pain because that whatever cut through the muscle or the skin has also cut through and damaged nerve endings. So that's going to be sending impulses to your brain. And you can take a look and read through this picture here. Here is a basic structure of a splinter going through the integumentary system or going through the skin, and you have bacteria entering, you have other structures being impacted just by one little splinter. #Queen.